Okay, I'd like to remind you of the fundamental theorem of algebra. Basically, if we see x to the third, we know there's going to be three solutions. And it could be kind of interesting how we get there. You might get a situation where when we factor that, we get two of the same thing. And so we have to list, plus 4 for here and plus 4 for here. But it still counts as 2, and this other one is the third one, so that would be 3. So if they're repeated twice, that's what I call a kiss, where the graph comes down and just touches the x-axis in one place, if there were two of them. If it's 3, it's going to go on through. If it's 4, if it's even, it's a kiss. All right. But the fundamental theorem basically says, if you have something to the third degree, you're going to have, if that's the highest degree, you're going to have three solutions. They could be repeated, they could be imaginary, but you will have three. So let's see what we have here. Identify the number of solutions or zero. So right away I say, I've got sixth degree, okay? That's the highest degree I can see. I see 3 here, and I see 1, and I see t to the 0. And those don't count because they're not the biggest. So it's the 6th degree, so that means that there's 6 zeros, okay? Or 6 solutions. So that's the simple answer, but we're going to go on and try to find the number of solutions. Well, we can look at the graph and we can see there's one right here and there's one right here, okay? And we say, okay, what are the possibilities? Well, I have 1 on top of factors of 9. So I have, let's see, 1 on top, plus or minus 1, and on the bottom, factors of 9, which would be 1, 3, and 9. So my possibilities would be plus or minus 1, plus or minus 3, and plus or minus 9. So I look at this here, and I see, let's see here, what would that be? Well, let's see, here's 1. That is not 1 over 9, negative 1 over 9. Okay, oh, I should have had the 1 here, sorry. What am I doing? I should have a 1 up here. 1 over 3, 1 over... Okay, there's a 1 on top, sorry. So it's not 1, and it's not 1/9. That'd be over here, almost 0. And it's not 1/3, which would be about right here. So, I don't know what that is, but it's not in my list of possibilities. And I go over here and I say, that's pretty close to 1. 1 might be a factor, 1 might be a factor. I could try 1. So anyway, it's a lot less than the 6 I was hoping for. In fact, it's less than the 2 I was hoping for. I saw where it crosses 2 places here, but it's not working out for me. So it must be a lot of imaginary roots, but I'm kind of hoping for 2 real roots. I know it hits in 2 places, so I got to have 2 real roots, okay? But already it kind of let me down over here. It's not on my list of possibilities. Let's see if 1 works out for me, positive 1. So I say 1, and I have 9 in this for t to the 6th, 0 for t to the 5th, 0 for t to the 4th, negative 14 for t to the 3rd, 0 for t to the 2nd, 4 for t, and minus 1. Okay, let's see if I get 0 for this root. Alright, so I have 9 comes down, times 1 is 9. I add 9. 1 times 9 is 9. I add again, 9. 1 times 9 is 9 again. Negative 14 and 9, they're going to fight, and I'll have negative 5 left over. 1 times negative 5 is negative 5, plus 0 is negative 5, times 1 is negative 5. I get negative 1 times 1 is negative 1, which gives me negative 2. And I'm really disappointed because I was thinking I was going to get another 0. So none of my possibilities have worked out for me. These all let me down. Okay, there are no rational zeros. I had a possibility of 6. 2 here, 2 here, and 2 here, and none of them worked out for me. Okay? One side, this side was obvious, nothing there. I was kind of hoping that would be something, but no rational zeros. Okay? So what does that mean? Well, I can look at the graph and I can say there's two real zeros which are not rational because they weren't on my list. What does it mean to be not rational? It means that I get a number like 5, 3, 7, 2, 8, 1, 6, 5, and I can never see a pattern and it just keeps going forever. Okay? So the two real roots that I see, I can see them with my eyes. They're not rational. I can't write them as a fraction because they never stop and they never show a pattern. If I see a pattern, if I see 0.3333, okay, there's a pattern. That's 1/3. I can write that as a fraction. But if I never see a pattern, I can't write it as a fraction, so it's not rational. But it's still real. And then since I know there's 6. I know there's 6 zeros or 6 solutions. So I have to say that the leftover are going to be imaginary, 4 imaginary. And there we go. And I'll have to leave it at that because that's as far as I can go. There are no rational zeros. There are 2 rational. There are 2 real, irrational, which leaves me 4 left over that are imaginary. Okay, there we go.